Hi folks, I'm back with a Marantz tuner. This is a Marantz 150. This belongs to a fellow tech, an old friend of mine named Mark. And he says the problem with it is it's not getting stereo. He's done a lot of work on it, and he had someone else do some work on it, so I'm not sure what I'm going to find. But he did warn me, and I can see through the top, that he left copious post-it notes all through this unit. So I'm not going to fire it up until I get the cover off, read the post-it notes or remove them, so this thing is not a fire hazard. But it looks like it's going to be interesting. And he warned me these are a little tricky to work on because there's a lot of plug-in boards and hard to get to everything. So without further ado, let's just dig in and see what we get. Alright, I'm pumping a pretty strong signal and I'm putting 1 millivolt in the antenna terminals, and I verified that what Mark says is correct because when I step through, this is a mono signal where right equals left. If I go to right equals negative left, I should have two sine waves 180 degrees out of phase with one another. And this should be my right only, and this should be my left only. As you can see, we don't have stereo. So I'm going to, and this tuner actually makes it fairly easy. There are two RCA phone plugs. Input from the front end, output of the IF. So I'm going to see what's coming out of our input to the IF on the spectrum analyzer, and then we'll see what's coming out of the IF. And we'll take it from there. This is one of those things where you take it one step at a time. Okay, let me rephrase that. Everything you should take it one step at a time. Okay, so I'm tapped off the front end here, and I'm just using an RCA cable. My spectrum analyzer over here is set for 10.7 megahertz for our center frequency. That's the frequency of the IF. Remember, it's going to come in the front end. It's going to hit an RF amplifier. It's going to hit a mixer. The mixer is a nonlinear device. It'll spin off sums and differences of the frequencies. And the difference will always be 10.7 megahertz. That's our IF frequency. So that's what we need to look at. And if we look here, we're a little off 10.7. It might get closer when we go through the front end and line it. It's not terrible if they're a little off, as long as it gets through the IF and everything's happy. And our amplitude is neg 42 dBm. That's also pretty good coming out of the front end. So I think our front end is probably okay. So the next thing we're going to want to look at is we want to look at the IF. And same thing here. I'm just going to pull this out, use an RCA cable, go in here. This is our in, this is our out. So we're going to take this, plug it in here. We're going to plug our front end back into the IF stage, and if we look at our spectrum analyzer, we can see mostly glare, but it's reading about neg 37 dBm, so it looks like it's putting out a pretty good signal. I'm going to have to go through the multiplex section and make sure that what we've got is good. By the way, this signal is an unmodulated continuous wave. If I put the FM on, it makes it very difficult to see what you've got going on because the frequency, of course, is now modulating. So we turn the FM off when we want to when we want to check our signal levels. Okay, so my friend Mark told me, as he'd been working on this, that there was a problem with the variable inductor in the front end, and he thought it was a cracked slug, but it's not the slug. It's actually the plastic sleeve that the plug sits in, I think, is kind of wallowed out, or the threads are gone. Because I can get this, he said he couldn't get it much better than 100 microvolts. I'm down to 8, and I got a good solid signal. But you can see, and I'm going to move the camera just a little here. If I just tap this, oh yeah, so if I just tap the turntable it's sitting on, I know there's a lot of glare on the screen. You can see there's no way this is gonna get back to them without dropping out of alignment. And I'm gonna try and give a better view of what's going on down in that slug. Also, this thing is gonna have to be restrung, and I'm gonna wait till the very end to do that. And I think I may be on the track of the problem with the muting circuit that's preventing stereo reception, but let me see if I can get you a good view of that slug down there so I can show you what's going on. Okay, so I've got this thing under the microscope here. You can see the one core moves around quite a bit when I just jiggle it, and that's why I can't get it to keep in alignment. If you look at the core next to it, and I have the tool in there, you'll see that the core itself doesn't move. The core stays still. The tube, or the housing itself, does move a little, but the core stays still inside the housing, and that's key. So I'm gonna have to think about how to address that. Meantime, I'm looking at the muting circuit, and one of the first things that comes into the muting circuit here at pin 1, H309, and you'll notice there are two voltages on here. We have one voltage which is supposed to be off, and the other one in parentheses is when the transistor is turned on. And when the transistor is turned on, it should pull the collector down to 0 volts. What I'm seeing here is when I have no signal, I don't have 0.1 volts, I have 0.2. The transistor should still be turned off. However, I'm seeing 1.1 volts. If I put signal into this thing, transistor turns on, it should pull the collector to 0. It's not. So I need to look at that and find out what's going on there. The transistor checked good in circuit. I may pull it out and give it a more in-depth test, but that's a problem because this thing is never comes out of muting. When the muting's engaged, you have no signal. So I'm going to look at that. I'm going to think about how to address that core, and let you know what I find out. All right, I pulled H309 and tested it. It didn't test bad. I replaced it anyway. But what I found was I didn't really have a strong enough signal. Remember, this is part of the muting circuit, and without a solid signal going in, you're really not going to see what you need to see. So now I'm looking at the collector of H308, and I'll pop the schematic up here. You can see that the collector of H309 feeds into the base of H308, and then the collector of H308 makes its way over to pin 6 of the muting IC. And with a solid signal going in, I have about 0.1 volts here. Let me see where the range is on this. There you go. And then when I turn the signal off, we get 1.1 volts. So it is switching, and it's giving what I consider to be a good enough signal to pin 6. I've checked all the voltages against the schematic, and the only ones I find problematic, and I'll show you, are pins 8 and 9. If you watch my fluke over here, I'll go down and measure those. So this is pin 8. We're getting about 0.725. If we look at pin 9, we're getting a negative 0.09. And they should be, according to the schematic, 0.3 and 0.4. So we have a problem here. And by the way, let me put some signal in because that will make a difference. So with signal in, we got negative 2.15 at pin 9, where we should have positive 0.4 or 400 millivolts. And back at pin 8, we still have the same 0.75. There may be a problem with the IC. I'm going to take a look because this is coming directly out of the ratio detector, both those voltages, and I think it's okay. So I'm going to have to take another deeper look at this and see what I can figure out. Okay, so I checked out the ratio detector, and it seems okay because when I pulled the multiplex board out, the voltages I was seeing went away. So I think they were leaking from inside the IC. Now, a lot of times we suspect the ICs are bad, but they're fairly dependable. However, they are until they're not. And in this case, replacing the integrated circuit for the muting is what fixed our problem. Because now if I turn my pilot on and I go to right equals minus left, you'll see we have our sine waves 180 degrees out of phase. If I go to right only, I get right only. If I go to left only, I get left only. And if I go to right equals left or mono, I have good signal. And if we look down at the face of the unit, we'll see something that Mark hasn't seen in a long time, and that's the stereo lamps illuminated. Something else that's interesting is now the muting works, because if I press muting and I have about a 50 microvolt signal going in, we don't lose it. So the problem was the muting IC. I have to figure out what to do about that slug. I have to restring this. It needs a complete alignment. But yeah, that was our problem. It's a relatively difficult to find IC. I had very little luck finding information on it. I was able to find a reliable source to get a replacement, and I had it on hand because I had a feeling that was the problem. Mark, I think, was suspecting the muting as well, but anyhow, that's that part of it. Now let's see what we can do about that slug. Okay, so what I wound up doing to stabilize that slug was I wrapped it in Teflon tape. That will take up the voids, hold it still inside of the housing, and it's non-conductive. It's an insulator, so it seemed like the easiest thing to do, the most expedient, and it seems to be working. Right now, I'm at the high end, and I have my generator putting out 4 microvolts. So I can get recognizable sine waves at 3 to 4 microvolts. If I drop it to 3, it starts to tear a little. But that's pretty darn good. And if I turn it to 25 microvolts, I can get stereo. And that's also pretty good. Let's see, go down to 3. Okay, no stereo, 3 microvolts. Or 10. 15, we start to get a stereo signal. So yeah, that chip was the whole problem. And that chip is the muting chip. It inhibits the stereo operation. And I had a clue there was a problem, because no matter how strong a signal I put in, the muting control would just kill it. And it shouldn't do that. You should be able to set the threshold and have it come out of muting when you get a halfway decent signal. That's user adjustable. There's an adjustment on the back and another one inside. But that was the entire problem with the stereo operation. The last thing I'm going to do is the most fun, and that's restring this thing, and I'm going to put it through a full alignment, put the cover on, and give it back to my buddy Mark. So yeah, I'm probably going to have to restring this 3, 4, 5 times before I finally get it right. This one has separate front ends for AM and FM, so it's going to be just extra fun. Anyhow, I'll come back with that, and then we'll wrap this thing up. Okay, so as it turns out, I don't have to restring this. The problem I was having was that the tuner string had come off some of the pulleys here in the corner. There's 2 of them. You can see one here, there's another one underneath. And once I got the string run correctly over the pulleys, tuner started to tune in okay. Mark said there was some slippage if you tune slowly around the middle. That may be okay now. But the bigger problem is I was starting to go through the alignment on here, and when you do that, you have to go back and forth, high end to low end to high end to low end, and just keep tweaking it until it's good at both ends without any adjustment. And I noticed that my signal started to get way worse, and I didn't realize what it was, but it turns out that one of these little trimmer capacitors that sit on top of the tuner here had gone bad. There's a little piece of insulation in the capacitor here, and I saw it was sticking out the side. So I'm going to have to replace this guy. I've got a couple coming. They should be here tomorrow, and I'll pop that in. I should be able to complete the alignment. One of the things I wanted to talk about before this part gets here is why I suspected the IC, even though they're not that often the culprit. And like a lot of people, I have ordered ICs and replaced them because I was sure that was a problem, only to find out that the symptoms remained unchanged. And I've purchased some expensive integrated circuits and learned that lesson. So the first thing I want to do in something like this is see if there's voltage issues and if they are coming from the IC or something feeding into the IC. And I did that by pulling the multiplex board and seeing that the voltages I was seeing were not coming from the ratio detector. It's kind of convoluted, but they come directly in the edge connector from the ratio detector to the multiplex board. So just pulling the multiplex board out, I could see that the voltages were coming from the multiplex board and not the ratio detector. And the other thing is, if you look at this block diagram of the muting system, it shows the chip has a Schmidt and AND gate. AND gates are logic gates whose output is only high when both inputs are high. So you have to have if it's a TTL or digital level, it would be considered 5 volts. I don't think this is, but anyway, you need to have voltage at pin 6 and you need to have voltage at pins 8 and 9, close to what the schematic specifies. And you can look at the output of the AND gate at pin 7. Now, there's no connection on the multiplex board from pin 7, but you can look at the output of the Schmidt and AND gate. So it's a Schmidt trigger and AND gate, and it didn't change. And that also made me suspect the IC, because I had changes at pins 8, 9, and 6, but I wasn't seeing any change at pin 7. Again, that's what made me suspect that the problem was the IC chip. As I've said in the past, I have purchased some pretty expensive ones, and it wasn't the case, so I like to make pretty sure before I pull the trigger and order one, especially if they're expensive or hard to find. All right, so I received the parts I ordered today. These parts are from Jameco, who I bought parts from before, but they were fulfilled by Amazon, so I got them in one day, which is great. And they look like a really good match. This is the old trimmer capacitor here, and this is the new one. They look like a pretty good match here. Now I'm going to solder these in. This is going to go on top here like this, and I'm going to do it off camera because I don't want to get distracted and burn through the tuner string. You know how I am about tuner strings. So anyway, I'm going to solder this in and going to start the alignment. I want to put the cover on for this final alignment to make sure that everything is just right on. Okay, so I've got the capacitor, the variable capacitor, soldered in, and it looks pretty good. It looks like it's lined up pretty well. I put the inner cover on just to see if it was going to line up with the holes. It looks like it is. So I'm going to put both covers on and start going through the alignment. Okay, so I've got this thing aligned and all put back together. I was going to put the alignment in the video, but it turned out to be a lot more involved due to having to align the oscilloscope too. But I got everything dialed in. You can see we got a good stereo signal. If we go mono, it turns into a straight line. That's muting. If we go mono, you get a straight line. This is what stereo looks like in the scope. And I'm going to put the volume on so you can hear it, but I'm not going to rest on any station too long to try and stay away from any copyright violation from YouTube. So here we go. We have a station all the way at 107.9, I think. I got a chart from FM Fool, and I'll put a quick screenshot of it up here. And you can put in your address, and it tells you what stations you'll get in descending order of strength. So it's really helpful when you're trying to diagnose a tuner or just determine if it's pulling in stations and not check the sensitivity. There's a word I'm groping for. Anyway, evaluate was the word I was groping for. So turn the volume up.
You know, overall, though,
Time if you're driving in Broward County, but
Yeah, it's Nick Rivers, local.
Okay, so I'm going to put the muting on now, and I'm in my garage. It's kind of shielded. I have an indoor antenna here, but I do get a fair amount of stations in stereo in here.
oh, you.
Wrong in your own mind.
So anyhow, this thing seems to be working really well. With a good antenna, we'll get a lot more stations. If you look at my, this is a screenshot taken from my spectrum analyzer. It shows basic signal strength all the way across the FM band in my area. I just have an antenna on the input of this spectrum analyzer. It's right on the edge here.
Por acá contigo recibiendo saluditos. Santiago, que ahora está trabajando, es camionero. Y gracias.
More. I need to see that.
In those days, they.
Turn muting back on.
Until the time he goes to bed at night. I came across a letter that was written by a communist.
Now, this is a very strong station, but I've checked with other tuners. They're broadcasting in mono. I didn't know anyone did that anymore, but it's probably cost effective. But anyhow, we're looking pretty good here. I'm going to give this back to my buddy Mark and move on to the next project. He referred to this as the tuner from hell. I think what happens when you're working on something and you can't fix it is you reach a certain point where you just spinning your wheels. That's why I tend to set things off to the side sometimes, and that often helps. Occasionally, I don't get back to them. I do apologize for that. I know I have a Luxman and the Tektronix scope I haven't gotten back to. I'm still girding my loins to get back to those. But anyhow, I'm going to give this back to my buddy Mark and cut this video off right here. As always, thank everyone for watching, and I like giving back to the community that's given me so much. Thanks a lot, everyone.